The question is why we select minus 10 dB line to decide the bandwidth of an antenna, right? So to decide the bandwidth of the antenna, actually it is desired that whatever the power be paid to the antenna, all power must radiate. But it is only possible when the source and the antenna, which is I'm considering as a load, must be matched to each other. But practically it is never possible, or I can say it is impossible to match. Okay, so what antenna researchers decide, uh, they decided, okay, if 90% of the fed power is radiated and only 10% is uh, reflected back, those range of frequencies will be considered as bandwidth of the antenna. Now if you see this formula, so it tells that S11 dB value is equal to 20 log base 10 S11. Now what we do, we put S11 value is minus 10, so I'll put this S11 value to the minus 10, right, and I put it minus 10. So now I need to find the S11 value, and the S11 value is given by this. So from this equation, if you find out S11, so the S11 will become 0.316, right? And now what is S11? S11 is the ratio of a reflected voltage to the incident voltage. Now for the power, the reflected power and the incident power will be related with S11 square, right? So that means the reflected power is equal to S11 but I use this, so it will be S11 square into the incident power, right? Now so when I put this, the reflected power will be equal to 0.1 into incident power, and as we can see, and as we are aware of, the total power is equal to incident power plus the reflected power. So it means whatever the okay, so it means that whatever the power is incident through the system, only point 1 of that incident power is reflected back, and when we convert that point 1 into the percentage, it will be around, it will be 10% of the incident power. That's why we have selected a minus 10 dB line to decide the bandwidth of the antenna.